Okay, let's get started. Uh, hey, Vilchris, thank you for joining me again. Um, actually, let's go back and do just a overview first. Um, okay, so Vickers, you mentioned that um, one of these you made a small change to just now.
Yeah, earlier today into the improve account pool performance pull request.
So could you briefly
I,
describe what is this? Because
so I made initially I made some changes to how the rebuild functionality works in the account pool, but after some further testing, I realized it introduces some potentially it introduces some new problems, which are it's for those problems to actually happen. It's a pretty edge case, but still, I think I think we're going to have to further consider how we want to, or if we want to improve the functionality of the rebuild in the account pool, we need to further consider how we should do that.
got it. So this
But it's a pretty
is
complex explanation, so I'm not sure if I want to get into that right now.
Yeah, makes sense. Did you want to mark this as, I think in GitHub it's WIP work in progress? Um, is this still something that's eligible to be merged in right now? Are these changes still a net improvement?
Yes. So this only takes out the improvements regarding the rebuild function in the account pool, but all the other changes, which is the I guess the core reason for this PR, those changes are still valid and they're here in this PR right now.
Got it. Okay. So I'll have to.
So yeah, that pull request is valid as it is now.
Okay. I know this 45 is pretty simple. I mean, you said this was mostly on. You said you got this on Windows. Um, Ideally, I would like someone to be able to replicate this and confirm that there's a fix here. Unfortunately, I don't have a Windows box. I should probably get one, considering that it's a pretty, it'll probably be a pretty big serious target or target, deploy for serious. Um, is that, do I remember that correctly? That you ran into this on Windows?
Yeah, it was on Windows, but I'm not. Yeah, so I haven't tried on other operating systems. But I think I said last time I'd be surprised if this issue, or well, maybe it doesn't appear on other OSs. So yeah, I'm not sure it should be tested.
Okay. So this morning, about 3 hours ago, uh, I woke up and started reading 44 again on my phone, and then at 8 o'clock I got up on my laptop and started, digging in. So, all right,
Okay.
let's get into this one, right? I think this is kind of the meat. So I
Yeah.
put together just this little review doc. So what I did was I used GitHub's built-in VS Code. I checked out your branch. I just did a git reset. That's my alarm. Sorry. I just did a git reset. Um, back to master so that all the changes, I could easily flip through them. And then I just kind of started uh, this little document to keep track of my notes.
Okay, nice.
I
Nice.
think, to be honest, we're not going to be able to get through all of your changes. Um, I think what I got through was kind of the so let's just go in. So you mentioned that there's kind of three things that we have this cache for, right? Um,
Yeah,
Plasma fused, the amount of committed plasma, and sporks. Um, so
right.
I kind of just started looking into these two. Um, all right, so I said, let's first kind of define the problem. So we see supervisor go. And the supervisor go. Oops, let me make this permanent. All right, so supervisor go. Sorry, let me get you there. No changes. All right, so in supervisor go, um, I mean, there's always a little further. There's always you can always keep stepping back a little bit until where this is actually called. I decided to, start here with this new block context because you've actually made changes here. So it seems like what you do is originally this new block context, it did the same thing every time, right? It got this momentum store. Um, Whereas now what you're doing is you split it up into two possibilities. It can either be an embedded or a user block. For the embedded, the logic is pretty much the same. You're just adding in this cache store. The user
Yep.
block is where the most notable thing here, right, is that you no longer have this momentum store, um, but you still passing in this, we're passing in this momentum acknowledged into the cache store. So
Yes.
my understanding here is that for the embedded blocks, because embedded blocks, they always acknowledge, is it the momentum that it's not the momentum that's called on, right? It's just the frontier momentum, right?
Sorry, could you repeat that?
So when an embedded block, sorry, an an account block created with the address as an embedded, address, the momentum acknowledged is always going to be, I think, frontier, right?
Yeah, it's going to be close to frontier. Maybe not. It's not. I don't. It's not guaranteed. I don't think to be a frontier, but it will use the send block's confirmation height as its momentum acknowledged. So it's very close to frontier.
Correct. So th- the issue where of having to go back to old momentum plasma states isn't really a concern when it comes to the embedded. It's mostly a concern, or it's only a concern really when it comes to user blocks referencing acknowledging very old momentums.
Yeah, exactly.
Okay. And from this new user account block context, we're seeing that we are not kind of directly getting this momentum store anymore. And so I just kind of wanted to define the problem for people. So, um, yep, so we split this into user embedded. This no longer needs a momentum store. All right, so if we actually see what this get momentum store is doing, let's get momentum store. All right, if we go to chain, in, Okay. So let's take a look at the interface first. I think it's this is the new one. Okay. All
Yeah,
right.
this is the
So
cache stores interface.
sorry, what'd you say?
The interface you just showed, that's the interface for the cache store.
Yes, correct. Um, yeah, I didn't make this document in a completely linear way, so uh, I think my point here is that so we have a chain here, and I think the important things here are that we have this momentum pool, and this chain manager and this cache manager that you add in. The problem is this chain manager, this DB manager. Okay, yeah. I'm just trying to show people the issue. I'm not doing it very well right now, but um, all right.
Okay, so
I think it boils. Okay, so what it boils down to is, yeah, I think I'm missing a line in here. I think yeah, what it boils down to is inside of this. All right, I think I have to go back to the supervisor. When we okay, yeah, when you run this get momentum store, what is this doing?
yep,
All right, this is the chain. That's why. What is this chain? This chain is chain.chain. This is an interface, right? Okay, chain.chain. Okay, this is implemented by this. This has the momentum pool and the chain manager, DB manager. This DB manager is also an interface. The tricky part here, I think, is this get, and this get is again, it's used. It's used here, I think. This momentum pool. Okay, yeah, this is the momentum pool. Lo- Long story short, this is a level DB manager, right? So if we go from Zenon Go, we see this new DB manager. This DB manager creates a level DB manager, and this is kind of where we run into the issues, right? So this get function,
yep,
this is where we run into the issue, right?
yeah. That's the problematic part.
All right. So yeah, this is it's kind of difficult for maybe people who haven't stepped through it themselves. Um, but at a high level, when when we're validating a block, we need to get the momentum store of the momentum acknowledged, and in order to do that, the DB implementation has to go and iterate all the way back. It has to do multiple rollbacks. Um, and that's what's happening here, right? At this get momentum store.
Yep,
Okay. And by doing this new user block context, we are skipping that, but we still need to see what functionality this momentum store is giving us. So new user block context, I think what happens later is um, chain, get frontier store momentum. I think what I looked at next was, yep, so it's the issue. Okay, so if we go back to supervisor, I think this creates a, yeah, this account VM context, right? That's what we're returning. So we can take a look at account VM context. Okay, look at account VM context. I think important thing to note here is that we're able to, this returns a momentum store. You've added in the cache here. Um, okay, that looks good. Okay, so that's the issue. And if we go back to, if we go to VM now. All right, so at some point, where's the, okay, right. At some point, it's difficult to decide how much detail of the stepping through to do, but all right, at some point this available plasma gets called, right? And we can see the old and the new. So for available plasma for the user, when it's a user context, right, we no longer have a momentum store to use, but both the embedded and the user store, they have this cache that can be used, right?
Yep.
All right. And so um, we're just replacing getting the chain plasma and the stake beneficial amount. We're changing that, getting it from the momentum store from the cache store. So, and this is
Yep.
all right. I think one thing I wanted to discuss with you, sorry, was, yeah. So this is a drop-in replacement. I guess we can skip this. Um, just noting where everything is. Um, one thing that one thing I wanted to talk with you about, yeah, was this. Um, so I think when I had originally was thinking through this, okay, so let me actually go through. This is get chain plasma. Let me find where this is. Where you actually iterate through this, I think that's in account store, account context. Okay, it's that store, new store. Okay, so not in store, account. Okay, yeah. So here we have those two functions, the get stake beneficial amount and get chain plasma that are now being called. They are um, calling this find value, and this find value is, no, I think here, right? Find value. Um, so of course, one thing that I wanted to ask about was you start from the frontier and you iterate backwards, right?
Yep.
Okay. I think when we're talking about this conceptually, one thing that I had thought was, is it possible to start from confirmed and go forward? if that makes sense.
Yeah, yes, it's possible. And so you're meaning it's iterated from basically the first key in the database, and then iterated to the last.
Correct,
So
because I
basically in
think
reverse order than what it's doing right now.
correct because I think the number of iterations you do will be less on average. Um, because if you're sorry, this is like for I think for most people watching this, they're gonna have absolutely no idea what we're talking about. Um, but um, if you're if you're iterating from the frontier backwards, m- most of these are going to be applied the other way around, right? So the idea here is that there could possibly be maybe multiple unconfirmed transactions or states that have to be iterated through. Um,
So what do you mean by unconfirmed transactions? Since in the cache will only have confirmed transactions in it and confirmed states.
okay. Um, but then when a new one is being applied, yeah, the okay, I need to write it down properly what I'm saying or what I'm trying to say if it even makes sense. Um, but okay, in any case, this is pretty straightforward, I think.
So just one point I can make about the why it's iterating from the last to the first is that it work like if we change it the other way, and that's how I had it first. I was iterating from the first to the last at first, but then that only really works if you're pruning the states, the discarding the old states that you don't need, because otherwise you're always going to be starting from the first state change and iterating through all the state changes until you reach the current state that you're looking for, right?
Correct. Yeah. So
So
I
it
think if
works.
I is there a reason why you can't discard as you go?
Well, it works for states that can be discarded, but then there are some states that you may not be able to discard. I think,
For sporks.
for example, the plasma states they can be discarded, but then there's some stuff like the sporks. There might be an issue there that you can't discard any of them. But of course, sporks, it's not like there's going to be hundreds or even tens of them.
Okay. Um,
So that amount will always be small. But then if we're thinking there might be, or there are other use cases for using the cache, and there might be some use cases where we don't, or we can't discard the old states. So that's why I chose to iterate them from the last and then go backwards.
yeah, that makes a lot of sense. For the ones that can be discarded, I think what I'm trying to say is that the total number of iterations, I think, because if you're going from front and back, I think you're going to be hitting those front ones. Um, you might be iterating over them quite a bit, or I I think if you go from
Well,
back forward, it can be you iterate through that, you get rid of it. I mean I think the number of
well,
iterations is going to
well,
be small and bounded for the most part. I'm just
Yeah.
I don't know if that makes sense what I'm saying.
Yeah, I get what you're saying, and I think, well, yeah, first of all, it's, I think either way you do it, as long as you're pruning the old states, it wouldn't, like, performance wise, there's probably not really a that significant of a difference. But if we're thinking, like, for example, if we have an account and there's an, like, we have Alice has an account and then Bob has an account, and Bob is constantly, let's say he's fusing more plasma to Alice's account, right? So Alice's plasma, the fused plasma amount will be changing like continuously, and this is kind of the use case where you need the cache, and then Alice references, probably Alice will reference, the latest height, or the some like a frontier height when she's sending a transaction, right? So she would need the frontier state, and then if we're starting from the last one, we'll get the frontier state first.
That's true. I think it depends on if we're designing for, yeah, going from going from front to back probably fits the expected use case. Whereas going from back to front, if there is any difference at all, right, materially, would benefit more um, the referencing old momentums issue.
Yeah, yeah.
Um,
But yeah, but still, like I said, the iteration is extremely fast in level DB. So even if you have to iterate like 100 or 1,000 states, either way you do it, it doesn't really. It has a pretty minimal effect on the performance.
yeah, makes sense. Yeah, I think in practice it's just gonna be okay. Are we gonna go through three things, one, two, three, or three, two, one? Like at most, I think realistically that's what it's gonna be.
Well,
So,
yeah, 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 exactly. That's what it's going to be.
oh yeah, but just from I don't know. Sometimes I think too much about it. Um,
No, no,
okay,
it's good. I mean, it's an interesting question. Yeah.
so that's pretty much the read flow, right? It's I guess one thing to note is that so we're moving the iteration from having to iterate through all the momentums to get a momentum store, and then from there it's a constant lookup for the account store, and then um, the chain state or the chain plasma, and then those are constant lookups at that point. What we're doing now is we don't have to iterate through the momentum store, but we have very small bounded iteration when we're doing the actual getting of the plasma states. So we're
Yep.
changing the complexity. We're shifting it a little bit here and there, but um, overall, it's a huge difference. Okay, so That's that's kind of the read functionality of the plasma. I was starting to get into the right stuff. Um, yeah, I don't actually have too much here. Let me see. Um, so yeah, I guess if we go back to the cache. Okay, so at some point, this apply momentum gets called. I think I how's that being done? Right, because we're modifying this account VM context, and the account VM context returns the momentum store. Um, if we go to supervisor, apply momentum. All right, so when we apply momentum, we're calling this. we're creating a new VM, and then we're applying this. This is, how are we getting this again? This is apply momentum detailed, not momentum. Yeah, at some point, it's like I stepped through it once. Do I want to find it and step through it again? Um,
Well, so we can look at the starting point of where it starts. Let me let me find the file. It's in, so it's in chain underscore bridge.go. That's kind of the starting point of where it all starts happening. So here we have the here. So now when we're applying the momentum, we've applied the transactions, and now we
insert chain. Okay.
so this is basically when the node receives a new momentum, it will apply the changes into the database in this function.
Okay.
And so, right, so then after we've created the transaction to update, that will update the moment or the chain database, then we have all the changes we need to also update the cache. And that would, the update cache function is implemented in, it's in
Store
cache.
or
It's in cache go in the, it's here. So here we have update cache. And so if you look at the arguments that are passed to this method, we'll have the detailed momentum, which, and just if you don't, or anyone who's listening doesn't know, the detailed momentum is basically the momentum, but then it also has the account blocks, like the full account blocks in that object. So it gets the detailed momentum and then the changes, which are it's the patch that contains the changes the momentum has or is going to do into the database.
got it. And I see here now. Yeah, right. It's here's the update. Here's where we're calling the apply momentum onto the store.
Yeah, onto the Frontier store, we're applying the momentum.
Okay. And then this is where that extractor comes into play, I believe. Because yeah, when we apply the momentum, we now create this extractor.
Yep.
Okay. And this is the extractor. And so this is just the way this is just how we're getting things in and out of the database.
Well, so the extractor is basically this is like a patch extractor, or sorry, a patch replayer, I think it's called, which you can. Um, I don't know if they're provided, if it's like a level DB implementation or if it's a higher level implementation or own code base, but basically you can, like, we have the patch that contains the changes, uh, the momentum's changes, and we can replay that patch with this cache extractor, and it will basically call the put and delete functions or methods for each key that is in the patch, and then we can determine what we want to do with that key here in the cache extractor. And based on that, we can create a new patch where we then have the changes that we want to store in the cache database. So here, if you look at, we have the put. So this will be called when there's a put operation in the patch because it's iterating through the different operations of the patch, if that makes sense.
Yep.
So once there's a put operation for a given key, then we want to check, is this a key that we're interested in? So that's what the try to get cache key method is doing. So, and if it's a key we're not interested in, then we're not going to add it to the extractors patch. But if it is a key that we're interested in, so we're interested in caching the chain plasma, the fused plasma, and then the sporks.
Okay. Yeah, that makes sense.
So if here, for example, there's the common cache fused plasma, so we check the key. If it's the key that responds to the, it's a little bit upwards, get cache there on line 30, sorry, 40. So we're going to check if the patch's key corresponds to the key that holds the value for fused plasma for an account, if that makes sense. So we can then extract the beneficiary's address for that fused plasma, and we call the get height key method, which returns the composite key, so that we're basically storing in the cache, we're storing the value of fused plasma. For the key for that value will be the a combination key that has the beneficiary's address and then the momentum height at which that value is true, or when that state change has happened.
Um, I'm trying to think how to. I think the next step for me would be to maybe create a flow chart, or I forgot the name of that diagram type. Um, yeah, I'd like to create some sort of diagram for people just so that they can see this at a high level. Um,
Yeah, sure. I mean, it's pretty complicated in how it all works.
yeah, I think we would want to highlight the okay, we have a new data structure, we have this new cache store. Uh, Previously, I'd want to illustrate previously we went through this momentum um, store retrieval path. Now we have this new thing we're going through here. Here we have this cache extractor. Here's how it communicates with the database. I think something like that illustrates at a high level would be good. Um, I mean, a lot of the other changes, just going through this list, are kind of just making sure types and arguments are okay, right? I mean, we do a little bit more for the sporks, um, but is there anything big that you think we haven't covered? I guess besides some of the spork stuff. Um, yeah, I feel like today my goal was kind of make sure to confirm my understanding. Um, I guess yeah. Next thing would be I'll try to help document this a little bit. Um, this is a bit pedantic, but do you think there are any piece of this that can be broken out into their own, either its own commit or its own MR? Super pedantic of me is I think some of these delete functions. Um, is do you think there's a logical way to kind of split this up?
Um, well, I'll need to think about that a bit because I think, well, yeah, because at least you can't, well, you need to write the changes into the cache so that you can use it, and either one of those isn't there, then
Yeah, that's why I said it's like maybe this delete thing, but I don't know. Like this could be a commit before that, but that's not super important. But if there's anything bigger than this, it has to go
right.
together.
Okay. Yeah. So okay. So you're concerned about the delete part of this.
I'm just because right now this is um I think your PR is two commits. Um, I'm kind of in this school of thought of so I think people generally have different schools of thought whether do you want commit history to represent what actually happened or to be some sort of narrative that you tell. I tend to fall into trying to have like fairly atomic commits that can be stepped through back and forth. Um, or when you're debugging, you can search through the commits and things like that. So I'm just wondering. Yeah, the we have to have read and write go together. Um, does Spork have to go with Plasma? And that's why I'm wondering if some of these kind of helper things like the deletes can go into their own at least commit.
So do you mean if can Spork be? So are you asking if we remove the spork from this, would it still function, or can we make it work so that the spork isn't fetched from the cache? Is that where you're getting at, or?
Well, I think we want it to be. I'm just from a review perspective, from an ease of review, from a um, granularity perspective. Do you think do you think there's any ways that we can break this up into smaller bits? And if the answer is no, the answer is no. Like I said, the only thing I could
Well, I mean,
do is
probably. Probably it could, but maybe I'm not that used to working that way that I would start after the fact. I would start splitting the work into smaller commits. So I'm not really familiar with how that would actually be done.
yeah, it's so like for example, right? I've gone and so I took your branch, right? Um, and I've reset it against master, and from here I could pick and choose which files to go. Um, if there's a way that we can, so when we review this, we have all these files change. That's one way we can review it. I guess what I'm saying is there a way to break this down where we could say, okay, here's one commit. It's logical. It's its own logical thing, and I can change all the files change here. That makes sense. Then I go on to the next commit. Okay, that's everything to first thing could be, hey, I'm adding these delete functions. Next thing, okay, I'm using these delete functions. That's kind of all I'm suggesting. But like I said, that's kind of a school of thought of making your commit messages have a narrative as opposed to reflect how things actually happen.
Yeah. Okay. Yeah.
We don't have to
Well,
do that.
I
That's
mean,
I'm trying to think how we can document this a bit more, and through the commits is just one way.
right. Yeah. Well, I mean, so it. Yeah. I mean, it probably could be split into like logical smaller bits of like parts that contain a certain piece of it.
Yeah, and arguably it's more important just to get this out. Okay, so I think what I'll do is I'll review the I think I need to review the extractor a bit more. Um, I'll work through um, the Spork workflow again. Um, I'll try to run. Do you say how you added a benchmark test, right?
Well, not for this. So the only benchmark I had on this, which was in the commit or the PR description, was kind of an ad hoc benchmark that I ran.
Okay. I think it'd be good if someone, myself, could replicate it. Or how did you run this benchmark?
Um, well, I basically timed the function. It the I think it's in the insert chain function that we looked at, and when it's applying the momentum, I timed that, how long it took to apply the momentum into the database. And yeah, it was just an ad hoc test, so I added some timings there
Okay, I think that's going to be
and recorded.
a pretty useful thing. Could you could we get that into like? I guess I'm asking you. Can you put like a step by step how someone would do that? Because I think that's going to be really useful in the future too. When we have certain, yeah, I think it'd be super useful to say, hey, with this change, we can run this on this momentum, and it took X time, versus this change, or this this state of the code, and we get this. I think that's something um, we want to be able to do in a pretty sophisticated way, I think. So anything that anything if you have any steps you can provide for that, or how you did it, um, I think that would be a good step.
Yeah. So, well, at least in this case, it's because it's a bit hard to reproduce this benchmark because you would need the you would need like a snapshot of the height that's before that problematic momentum so that you could actually test that momentum to see how long it takes to process it.
Is that what you created for this? A snapshot?
Yeah, yeah, I have a snapshot of it, yes.
Okay. So yeah, it's a bit. It gets into something. It gets into a bunch of other things, but let's take it offline. Let's talk about how we can create those snapshots. Yeah, this is outside the scope of this review, but I think we can think about how we can make a lot of this testing repeatable.
Yeah, I mean, it would be good if others can test and confirm it as well. But I mean, I haven't put a lot of thought into how that could how we could actually make that happen, though.
Yeah. Um, I mean, ideally, we wouldn't need, an actual node to run, right? It's load this file or, data set or something. Here's the momentum that's coming. Run this and time. Like we can put it into a test function, I think. I don't see why not. Um,
Well, it depends.
yeah.
It depends on what you want to test. Like, do you just want to benchmark it, or because the you only like you need to the data set or the database has to be pretty significant for the performance issues to start appearing. So I'm not sure how, or well, maybe it is feasible to do that in a test, but you might have to run it for a long time to actually fill the database up with dummy data so that you can test the performance of accessing some old state in that database.
Yeah, I wouldn't imagine that kind of test to be something, you know, that's always run, but I think it is something we would want to get into code where um this is something I'm thinking about too with regards to some of the operations work is can we have scripts that, spin up a what could a test script look like here? Spin up a VM in some cloud provider, download a state, um, and then get some results from that. That could
Oh yeah,
scale
so okay,
really.
you're talking about like a yeah, so you have additional infrastructure to actually run.
Yeah, that costs money, right? But I think just
Yeah.
I think that's something we'd still want to define. And if we can, yeah, I guess we start just by here's a step-by-step instruction, and we can get it scripted out. And then I think that's not something developers run, you know, actively all the time, but that's something we probably want to run, before a major release or things like that.
Yeah, that makes sense.
'Cause I do think we should strive for reproducibility. Um, so I'm just trying to think how can we make it so it's not just you saying, "Okay, I've done this." What's the easiest way for us to do that? Is it just you sending someone else your benchmark and then they do the exact same thing you did, or you give someone the instructions how they created the benchmark? Um, I'm sure there's a lot of people
Well,
who'd be willing to do the test, but what's the closest we can get to reproducibility right now for this?
Well, we did this with Cryptofish a while back, where I just sent him the snapshot, and I sent him the diff of the code that added the few lines that timed the function.
For this particular change?
Yeah, for this exact change. Yeah, and he ran it on his in his environment and just confirmed that yeah it works.
Okay.
Or yeah, so that's how we did it with Cryptofish.
Yeah, again, maybe a bit pedantic, but I think it'd be good for him to comment this, that he ran those. Just just set a precedent, right? I think it's we want to demonstrate that we're able to reproduce things. So yeah, if this has already been reproduced, let's get that in this commit some. Let's get that in this MR somewhere.
Yep.
Yeah, I'll read that right now. Let's say, no, what is he? Oh, he's not. He's not in this repo, right?
Yeah, apparently so.
Okay. Yeah, I'll find him. I'll send a message and just say, hey, Vickers mentioned you had reproduced this. If you could comment on your results.
Well, okay, actually, one thing is that it was with the older version with the that used the partitioned
Okay.
approach. So yeah,
Okay. Well,
so actually it's not valid for this PR, I guess. Then yeah, but yeah, but that's I mean maybe he still has the snapshot. So if he's willing, he could run it with this new code.
yeah, we can ask. I mean, I'm happy to try and run it. Um, but let's think about how we can turn it into a repeatable process. Because I mean,
Yep.
this is definitely not going to be the only time where we want to demonstrate something like this. Okay.
Yeah, that's true.
We're at the hour. Um, do you think do you think there's anything else kind of major that we need to go over for this? Obviously, I need to make sure all the I's are dotted and the T's are crossed on this. A lot of this is kind of just um, adding in arguments, making plumbing. There's a lot of stuff is just plumbing. Um,
Yeah, yeah. Many of the changes in the files are just basically non-functional changes.
um, okay, yeah. So I
But
guess
yeah, I
we.
mean,
Sorry, go ahead.
yeah, it's just, I mean, well, it's good that we're having these reviews and but this is because this is a pretty big change and this a and it has complex elements to it. So yeah, I think we need to kind of think also how are we going to document this and like how do you like how does someone like you who's you have a pretty good understanding of the network and how the code base how the network works and how the code base is structured and all that. So but like of course even for you it's not clear as day like how what these changes mean.
I'm a bit rusty, but I'm
Yeah,
sure
well, but
that
still, I
yeah,
mean,
exactly. It's not everyone is like even thinking about this or familiar with this code. So yeah, I I'll try making a diagram. I think that's a good place to start in terms of helping with that because I mean even this repo, right? We need three approvals. Um, this is
yeah, yeah, because
go ahead.
yeah, it needs three approvals, and it's. I know that you've spent time looking at this, but then we're going to need two more approvals, and and like it's just, yeah. I mean, I don't know
So,
if or I.
real
Mm.
question: what do you think the threshold of review should be, or what kind of standard should we have for this review? Given that this is more performance, um, what what do you think would be the appropriate amount of review for this? I don't have
Well,
like a
I mean, it's
perfect
hard.
answer for that.
Yeah, it's hard to say because, like, obviously, I think a reviewer should check that it's not doing anything, like
Malicious
stealing
start.
user funds or, yeah, anything malicious like that. That's of course like the first priority, I think. But then there's because there's also a certain risk, like because the things that this is changing, if there's a bug somewhere, it might cause the node to just, you know,
Yeah, you could have
to
a
crash, for example, and
fork.
you
You
could
could
have
have
like a, yeah, it could have like a pretty bad result for the network. So there's also that risk. But then at the same time, I mean, it's such it's a big change, and it's a complex there's complex stuff in it. So I don't really know what I can expect from other reviewers and from other community members
so
to
that kind of goes
realistically,
back to my ask
um,
of if there's any way to split it up, even if it's simple things such as, right? It is there is there a way for to break this into right now it's 45 files, right? And keeping the links between all of them is that I don't think I don't think anyone can kind of keep that in their head. Um, is there a way that we can like my example was pretty dumb, right? Like for the deletes, right? Like we have a couple of these the changes in here. Some of them are just okay. We're adding in this delete. It's not a huge amount, but we can reduce the cognitive load of reviewing by splitting this out into its own commit or something, and then they can quickly review that and say, okay, we're adding in a delete. I know that's available now. I don't have to think about that this is part of the change at all. Um, that so yeah, and I think maybe if we get it diagrammed, and I think that will start to show lines where we could carve this up. Um, but yeah, it's kind of funny because yeah, I guess performance change. It's we're not adding new functionality, but it's pretty far reaching. Um, it's fairly invasive, I guess. Whereas doing like an embedded change, it's fairly contained into like a few new files.
yeah, yeah, yeah. Because that's the thing with this change, is that it touches so many parts of the code base that there's, yeah, like if you're reviewing it just like all at once, there's a lot to take in.
Okay. Um, yeah, let's talk offline about if there's some logical organization we can put around this. Um, I mean, I think I get it. Yet I have to thoroughly check everything, but at a high level, makes sense what this is doing to me. Um, I would have to. Uh, have you run like linters and everything on this? Sorry, again, this is me um, caring too much about the code quality at this point, but
Well, I mean, I have an automatic linter on my in my IDE, so I mean, it should be fine, but
Okay, that's good. Um, yeah, I guess Vigorous, we can end it here and then talk about next steps. It's the challenges of distributed software.
yeah, exactly.
All right, well, thank you for your time. I'll try to get this posted a bit faster than I did the last one. Um, hopefully, you know, yeah, let's try to get onto back into a cadence of this. I mean, I'm fairly free. Um, if did you think we want to do another session, or maybe we'll talk offline for a bit about what we want to do for next session? And we still have those other PRs. Um, yeah, I think that is a critical question. Is what is the threshold of review that we want to go? That what's what's good enough, but still keeps us, safe.
Yeah, yeah,
I think that's what we
yeah.
have to
We're gonna
figure
have
out.
to think about that a bit, and we can talk offline on what we want to if we want to have another session on what we want to talk about there and how we want to present things there.
All right, awesome. Well, thank you for your time again. This is, you know, really great work. I mean, this solves. I want to reiterate that this is solving like a very tangible issue that everyone has run into. This isn't some, um, theoretical performance fix of, you know, oh, we eke out 5% here or there. This is something very material. Um, so I just want to reiterate that before we end it. All right. Thank you, Vickers. Have a great rest of your day.
Yep. Thanks, George. You too. Bye bye.